Okay, let me open it up so I can see what Jim is saying, if he says anything. Tis me. Channel. I am live now. Yay, okay, that's good. Alright, Jim, if you're here, just say something. If you're not, it doesn't really matter. It's still being recorded for you. I haven't edited any of this yet.
Really quick, can you all tell me how I set this?
Yeah, okay, so make sure the device, it's set to multiple. And then in the top left, it should go to a slice drop down. And then you just click slice. And then you go apply. And then when you click on the little arrow next to your image in the inspector or the thing, yeah, you should have individual sprites. So yeah, you have a little mushroom guy, and you can select all of them and just drag them into the plane. It'll create an animation. It'll ask you to save it somewhere. It might take a little minute for Unity to not freak out. Might have to try again, yeah. Sometimes Unity's a fickle beast. I don't know why your cursor's freaking out like that. Very strange. Just try dragging one in and see if that actually. Nah. Okay. Oh, go in. You're in the game section. You need to be in scene.
Oh.
Yeah, there you go. Not a problem. All right, it's gonna ask you to say where you want your animation to be, and you can do your little doobly doo. Okay. So today, guys, as I mentioned, we have our lovely Unity screen and Sublime on the right, almost on the left, and we're gonna start making our movement again with a little bit more advanced logic, so our Mario can actually do his thing. So to start, I had a list of stuff I wanted to talk about. I should probably bring this on over to my monitor so I can read it better. Oh, okay. So we've used transform before to make our sprite move, right? Well, transform has a lot more stuff to it than just its physical location. As I mentioned in the first meeting, transform has everything from rotation to momentum to all sorts of things, and it's positioned in 3 space. And this is where we'll be editing it. So there's a lot of functions, a lot of little variables you can edit freely. And today we're going to be working with rotations, which are not vector 3s. They're kind of vector 3s, but they're not as pretty. You got to convert them to what's called a quaternion. A quaternion is basically Unity's fancy way of handling rotations. It can convert it back and forth between Euclidean geometry with 180 degrees and stuff like that. And it's quite nice, but usually it deals with floats. So we're going to be moving from this to this, and it looks gross, but I'm going to be just watching, stepping step by step. I'm going to be making our first function that's our function instead of one that's built into Unity, and it'll be called rotate. So if you go over to your move script, I don't know if you all have your Unity projects open or not. If you don't, I would open them, because it's going to be recorded. It's just going to be a little harder to follow along. If you're not doing it in person, because I can't help you. You can always ask in GameDev, but just a tad harder. I'll go a little slow as you set your project up. Hey Jim, can you hear me? I'm worried about my mic quality, by the way. Because it's saying it's not super loud, but it's something. Okay, so what we want to do is, if you guys don't know, if you guys haven't used C# before, or if you haven't used Java really, because this is super similar syntax, you just type your return type and you type your method name, and open curly brackets. And you're using mono-develop, Paul. I'm disappointed in you.
No, this is Visual Studio Code.
Oh, ew! I saw that little blue stuff in the top corner. That's like mono-develop's icon. All right, I'm less disappointed in you. I'm a little disappointed because that makes me sad, but it's okay. All right, so we're gonna make a method called rotate. I'm gonna move this over so I'm not completely blind, because I'm sure that would help all of you. And what we're going to do is we want to come up with logic for rotating our object. So if we go over to Unity and we select our Mario, which we're working on, let me select this one that doesn't have the logic. Some things you might notice in your inspector are its position, its rotation, and its scale. If you've messed with these at all, if we zoom in on the editor and I mess with the rotation, I can just click and drag on the X, and it doesn't actually do much. It doesn't seem to move. But why is it not moving? Question mark. Unity, please. Oh, there we go. Okay, it just wasn't big enough. All right, so if you start messing with your Y, you'll notice it actually starts changing in degrees. So 180 and 0, and you'll notice if you give some weird degrees, it gets a little more at an angle. That's because Unity is doing its best to project what you're viewing onto a 2D plane. It's not really great at it. So you'll see it's still the little rigid body, and its hitbox is a little diagonal. That's Unity's best guess at what it would look like if it was rotated like that with a weird X rotation. So let me get rid of that. But if I added a 90-degree angle, you'll notice our guy almost completely disappears. Actually, pretty sure it just did disappear. There we go. So that's not what we want. We want to be really careful to make sure our game objects don't just disappear from us. And if you do a Z, it gets a little, a little weird. Unity enjoys this, I'm sure. Oh wow. Wow, I just broke it. Okay, that's cool. There we go. All right, so yeah, if you'll notice, if you're doing a rotation, so how do you guys think we would change Mario from looking one way to another when he runs? Just logically.
Change the rotation, the Y rotation,
Mm-hmm.
to flip over.
Yeah, but if I was to do what would I, if I was to do something on, what would I do it with? So on what button push? Yes, Emmanuel? You don't have to raise, you can just talk. There's not too many people.
So, Mario is running left, so press the A key.
Uh-huh.
WASD. If he's left, if he's running right, you press the P key and it goes right.
Basically, yeah, that's essentially how you want to do it. Is you want to tell the game, hey, when I'm having an input that's going left, I want my guy to look left. That sounds about right, and we can do that pretty easily right here. So if I press left, I want him to face this way and make his rotation be 1 or 0. And if he's going right, I want him to face right by making his rotation 180. Now, what do you guys? Okay, this is kind of tricky, but do you know what would happen if I'm pressing right, but I change its rotation? What do you think would happen? Because it's changing the whole object's orientation.
Oh, it would change its velocity too.
Yeah, it would change it to the opposite direction. So when you start pushing left, I mean, he might look left by going 0, but then he starts moving to the right, and it looked very strange. So there's some math logic you can do in there. It's pretty nice, but I will show you guys that. So basically, what we said was, oh, that's not the right one. Come on. All right. So basically, what we said was we want to make our object. I'm opening the wrong Sublime. There we go. We want our guy to look right. So let's say we say our rotation, I should probably define this as a float. Our rotation float should probably equal 0, right? That makes sense because that's our Y rotation. So that's our default. So he'll always look. What is 0 default? Yeah, that's looking left. If I can do that real quick. So we'll say our quaternion. This is where it gets weird. This is how Unity does with angles. Is quaternion objects, and I can't spell worth a damn today, equals quaternion dot Euler. Now, this is fancy speak for saying, hey, I'm going to give you an X, a Y, and a Z, and I want you to turn that into however Unity handles your rotations, because it looks a lot different in math than a 0 to 360 degrees. You know what I mean? It looks very different. So, but for simplicity's sake, instead of doing the math ourselves, Euler basically converts it from our nice degree angles into its internal object. And then we want to say our transform dot rotation just like we did transform.position, which we did, or transform.translate, excuse me, up above. And we will just say that to equal our target. Oh, are you behind? I'm sorry. Do you need help?
No, I wasn't here last week, so I'll probably be
Okay, that's cool. Are you guys super behind? I'm sorry. For last week, basically all you need to do is, there is a post I made on the GameDev channel. I don't know if it's still there.
I guess after this, I could look at the recording.
Yeah, the recording should help you some, because I know my audio quality was a little jank last week, because I was using my laptop microphone because that's all I had. Oh, it's good. Okay, cool. Yeah, basically all you need to do is just add a single object and you can make it move with some of the logic that we use right here. This should be able to use for any game object that you attach a script to. Like literally it's just you're saying, hey, I want a vector 3, which is it's XYZ, and I want to move it based on some speed that I define and some change in time, basically. And then you'll just make that translate in space. I'm gonna move this a little down so it's not as gross on the, there we are. It's a little easy to read. All right, so anyways, back to our transform.rotation. And the only way right now this is not being called, as you've noticed. So let's say we want our rotation to happen before our object moves. So we'll just say, hey, why don't you just rotate? And just do that. Now if we run this, and this is our move, which should be attached to our lovely little Mario, and Unity decides to run, that'd be nice. There we are. Nothing really happens. My test one is working all fine and dandy, but the one on the right seems to not be working. I'm going to move this one off to the side so we don't actually see this forever and ever. Oh no. I really need to bring a mouse. There we are. Okay. But yeah, our test little guy with our move script, he just keeps facing one direction. So how would we take our input and say, hey, if you're moving left, go left. If you're moving right, go right. Or make this 0 or 180 based on the direction. The best way is something we've already done, and it's up here. Horizontal direction is your input.getAxis. Last week, if you guys weren't here, input.getAxis is Unity's way of saying, hey, I'm going to define these buttons, like A or D, or left and right on the keyboard, as an axis that goes from -1 to 1. So when I press left or A, I want that to be -1, or when I press right or D, I want that to be 1. So it gives us nice little numbers that we can work with instead of Boolean logic. And it lets you have, like, if you're on a joystick and you're pressing left, you'll only get like a fraction, so you can make a move slower. It's really, really helpful, really nice, and it's pretty cool. But we can take that same logic and we go, hey, if our, let's put this after, sorry, after we set our rotation, if input dot, I'm typing all sorts of wrong today, axis of horizontal is less or greater than 1, which means or greater than 0, which should mean it's going right. I should probably surround this in parentheses because this is how C# likes to work. Open curly braces. I want our rotation to equal 180 instead. Now this works all fine and dandy for now. It should work fine and dandy if I remember correctly, because I stayed up really late last night trying to remember. Yep, there we go. Now, the problem that we had that Emmanuel pointed out was if we change our rotation, our Mario is going to be looking the wrong way, because this is the physics, like its entire rotation of the object is looking different ways, not just its sprite. So now when you press left, yeah, sure, it's going left, right, like left correctly. But when you press right, it changes that direction to 180, which means now when you press it, its forward momentum is going the opposite direction. And we can fix that pretty easily, actually. And it's kind of silly how you do it. Oh, I'm getting messages. Come on, people, leave me alone. Not the time. The best way to fix this is going, we probably want, what is it called? Our horizontal direction, we change this to a mathf.absolute, which is basically C#'s library for math. Just like you have, import math for Java, this is basically C#'s way of doing that.
Put math at, does that mean that
It's a float.
does that mean there's a separate library for regular integers?
Basically, yeah. It's not really that important. You can just import it, and it has no, or you don't even have to import it. It just knows. So it's just a function you have to get used to, just like math dot like absolute value or square or something like that. It's our power or something from Java. Just memorization or just memory. You can if I haven't emphasized this enough, just Google Unity documentation, and anything that you want is right here in the scripting API. And you go, hey, I want to learn more about a transform.position. And you give all sorts of things that are related to transforms and positions, and the first one usually the one that you want. And it even gives you code examples. It's super helpful, super nice, and just pretty all around helpful. But yeah, this is how I learned about that, because I actually used the regular integer one for a while, and I was getting flat values. So when I tried it on a controller, it wasn't moving at angles or at different speeds. It was just moving at constant, which is not what we wanted. So if you want to float that can be like -0.1 or something like that, this is the best way to do it. So now if we do this, if I don't want to save the YouTube. Wow, it still highlighted YouTube. That's great. If we go back to playing now, we're probably still going to have an issue, which is now our inputs are reversed. Which is because if you're pressing left, you're actually getting a positive value instead of a negative value. And if you're pressing right, you're getting still a positive value, but with your different orientation, it makes you move in the opposite direction. So to fix that, it's super simple. It's kind of sketchy, but it works. It's just multiplying by 1f, basically. Like that. And now when you do it, this should work just fine. See, there you go. So when you press left or right, you should look a little different direction. It's pretty cool, huh? All right, now there's some cooler things that you can do. And have any of you guys played Paper Mario? Paper Mario is one of my favorite games, and I really love how when you move on Mario, you kind of rotate in space instead of just glitching like Mario's doing right now. And there are some cool functions that you can do with rotations and quaternions to make that actually work. So let me pull that up so I'm not blind again, and show you what I mean. Okay, so what you probably want to do is add another float up top on your rotate, and call that float smoothness or smooth or something, and just set that to 5, or set that to 1 for now. It doesn't really matter. You'll see what I mean in a second. And then, for the Paper Mario feel, we're gonna add, instead of this just transform.rotation, we're gonna comment this out and say we're gonna go transform.rotation is equal to our quaternion dot slurp. And slurp is a really funny word, but what that means essentially, I'm sorry, I'm going off screen. I'll just maximize this for you. Dot rotation, which is our current one, and we want to make that go toward the target in the time dot delta time times the smoothness. All right, now that's a lot of stuff, so let me break it down. Basically, quaternion.slurp is saying, hey, I know I'm going to go between this rotation and this rotation, so input 1 and input 2, and I know I'm going to take about this amount of time, which is time.delta time times smooth. So 2 seconds or 1 second or whatever, right? What that's doing is saying, hey, give me a fraction of that rotation and I'll go there slowly. So you can, because rotate is called every frame, right? If rotate's called every frame, then this will be called every frame, and every time it'll just get a little bit closer to its goal. So when we run this, if I can Control S this and open Unity again, it should work. Oh, yeah, there you go. See them go really slow and then disappear. There's another issue with that, and that happened a lot faster than I expected it to this time. But I can tell you what that is doing in a second. Look at how slow that goes, and then he disappears off the camera. But basically, you saw him go really, really slow turning around, right? All right, what that's doing is saying, hey, I am rotating my whole body at an angle very, very slowly. Oh, thank you, Jennifer. And so what that's doing, though, is giving Mario a really weird angle. So instead of like 180, it might give it like 90, which is enough to make it, I don't actually know why that didn't make him move. Okay, I guess Mystery Mario just disappeared. That's enough to make him disappear. Well, if you press forward while Mario's faced like this, he'll either go towards the camera or away from it. So what he's doing is he's still going back and forth, left and right. The problem is he's not doing it in respect to the camera. He's going it in respect to like his own direction, which is not what we wanted. All right, 180. There we go. Put him back into normal view, and we can fix that too, because basically GameDev is going, hey, I want to do something, and then finding a way to do it, and it breaks a lot of stuff, and you fix it. It's literally half the battle. So how we do that is we go every time we run rotate and we move, we want our transform dot position. So I got a little ahead of myself last time. I think we had already used position to be a new vector 3 that uses all of our stuff from our regular position dot x, and then I'm just going to copy this and do that one more time, change that to y, and that is 0. Because our z axis is our depth, which is what Mario was doing as he was flying in and out of space. And 10 is where the camera is. So if he goes past 10, we can no longer see him. But now every time we move and every frame, he's going to be put back on the z axis at 0. So no matter where he is in the world, we don't care. He can be as high up or as low down as he wants, but he'll always be on the 0 axis. So now when we do this, and frickin' Sublime is going to say, hey, please buy me. We play this again. Our little guy, and the other guy, is always going to stay on the screen.
So basically, the issue last time was moving around in space when you just wanted to move around the space.
Exactly. Yeah. And unfortunately, now, if you guys remember a long time ago when we first did this last week, we froze the rotation on Z. Unfortunately, there is no Z freeze position. And that's why you had to do that every frame. It doesn't really do much. It's actually not really that big of a waste of a call, because if it's not different, it won't care. Like, it actually won't perform the call at all. So it's not that big of a deal. If you try and freeze the Y, he'll just hang in space, in the air. If you freeze your X, he won't actually move left and right anymore, so it's kind of a pointless endeavor. What's up?
Real quick question. The spreadsheet I imported, it's like he's facing the other way, so the code works and he's like walking in the right direction. The sprite is flip-sided.
The sprite is flip-sided. Okay, what you can do, I think there is a way, now I haven't done this in a while, so I'm sorry if this is not correct, but you can actually do your sprite render and flip it.
Okay, that's easy.
Yeah, it's pretty nice. So even if you have your sprite upside down, you can even do like, hey, I want my Mario to be upside down, which we'll do when he dies, by the way. Probably not going to do that this week. We're already halfway through all our shenanigans, and we haven't even finished rotating yet. But yeah, I'm sorry. It's a little bit of a mess. Code is always fun, and you got to fix a lot of stuff. But yeah, now we have a Mario that whenever you press left, he does it right. But the problem is when you press right and then let go, if you'll notice, he keeps trying to go back left, which is, fine, except when it's not fine and you're trying to go right. So we can fix that. Basically, that is a problem in our logic on how we're calling rotate. If you noticed, we have our rotate set to as constant 0 no matter what, and it's being called no matter what in update. So every frame, he's always going to go back to left if he can. And that's could be good if you always wanted like your idle animation to be looking left or something like that, right? But the problem is that for Mario, our guy should look right if he was stopping looking right. You know what I mean? So what we can do is say, give an if. If our horizontal direction does not equal 0, we'll put our rotate in there. And don't worry, that'll cause another problem. But just for the sake of showing the problems, we'll do it. So now when you press left, I mean, he'll go left and he'll go right, but the problem is if you stop moving, he'll stop mid-animation, which is not what we wanted, right? We can also make him turn faster, but for the sake of showing this error, I thought it would be a good idea to make him turn slower. If you just increase your float for smooth, if you make this like 100, he'll turn super fast on a dime. If you make it 5, which is the nice one, which is what the other Mario's on, that's about the right speed. I think that's what the other Mario is. It's either 5 or 10. Yeah, there you go. See, look at that. It's pretty nice. But we can fix that too. And it's basically just adding a little bit more logic. What I have in mind is putting all of this to save simplicity, or to save some logic. We go, hey, I want all of my logic in a big if. So if my horizontal direction is not 0, I want you to do all this. So that way, every frame, we're not calling all of this garbage. We're only calling it if we're actually moving, which is efficient and good, because as I said last time, update is called every frame, and it'll try and do everything every frame. And the more you put in here, the worse it gets. And that is indented so incorrectly. I am so sorry. Let's fix that. There we go. That is not the right if for there. There we go. Okay, so now we have only if he's moving. Well, that doesn't actually fix our problem of rotating. So let's make a private variable up here, private float, and call it current direction. And we'll just set that to 0. And what we're going to do is so inside our if check for the horizontal direction not equal 0, we're going to say our current direction is going to equal our horizontal direction. So that way our object will remember, even if it's not actually moving at that very second, that it is or was moving in that direction. And what we can do is, at that point, we can go, okay, we can just take this if out of here and call rotate every frame, so just rotate. Else, rotate. Okay, that doesn't actually, again, fix our full issue because it doesn't know what current direction is. So we're going to try and pass it in current direction, and we're going to change our function to actually use that. Current direction. So instead of our get axis, we're going to just change this to if current direction is greater than 0, we're going to make that move right. So that way we don't waste 2 calls, and we can just keep our thing. Oh, I did this incorrectly. That's supposed to take a float current direction. As far as I know, that shouldn't break anything. Oh, I did. Rotate takes 0 arguments. It's because I didn't fix it up here too. Rotate current direction. Let's see. Did I call it right? Oh, yeah, sorry. So yeah, what I just fixed was basically I was calling rotate without giving it the proper parameters. So current direction is always going to be kept in the object. Even if this stuff isn't run, it'll just be changed whenever this runs. So if I am editing in left or right or whatever, it'll just always remember that. So if we run this now, we go left or right, see? Fixes our full issue, even if I'm just tapping the button, like left or right, just barely. And you'll see it's finishing its whole animation, even if I let go. If I hold it, oh yeah, he's still moving. And we're almost at exact feature parity of our Mario, which that is what we're looking for today, is our flying Mario. It's gonna be great. Let me get back to here. All right, so what is our differences? Right now we have, we slurped, we talked about quaternions, we made it translate, we did some nice math with absolute values. Looks like we did about just everything for our rotation. So yeah, if you just want to edit this, or you want your default to be like left, if you want him to like always look right when he spawns, you can just change this. Just go, okay, if this is less than 0, then I want to default this to 0 or whatever. Doesn't really matter. Pretty sure that works. Did last night when I tested it, but then again, 3 AM Braxton is not always the most person that remembers everything. Yep, there we go. Now when he spawns, he'll always be made to look right.
I think I did something wrong because he's only moving left now.
He's only moving left? Oh, did you make sure you did absolute value? Right here.
Yeah, I did.
You did?
It happened when I changed everything to that big.
That big if? Or the big if else?
Oh, I missed the line 18.
Line 19? Oh, you missed current direction equals horizontal direction? Gotcha. Well, I hope that's it. Hopefully that'll fix it. But he only moves left. How interesting. Are you rotating it incorrectly? Because if you're rotating it incorrectly, you might actually be switching the body back to a different rotation. So he might be looking left and going right, but then looking right and going left, which is basically the same thing. Yeah, there you go.
It just happened when I changed the rotation to 0.
Oh, what you probably did is you didn't switch the less than or greater than, or you didn't switch both of these values in tandem. I mean, I don't know. I can't see your code. It's a little small from right over here, but that's what I'm guessing. So yeah, if you enjoy your Paper Mario feel, the slurp is for you. If you don't and you want it to be quick and snappy and no time delay, then the regular transform rotation is for you. See, you can just comment it out and it works just fine. And you can have your little glitchy sprites all you want, all day, all night. Oh man, it's kind of cool. That's amazing. All right, now we're gonna make your Mario jump, and this is actually one of the easiest things. And I'm sad I didn't make us do that the first meeting. I just had forgotten what the rigid body syntax was. Essentially, you're gonna use a different update command, and I know that sounds silly, but you know how I said update's called every frame? Well, that can be as fast or as slow as you want, which can be good, but it can also be bad when you're trying to do physics on a specific sequence of things, right? So there's a function that comes with your mono behavior called fixed update. And it is called every fixed frame, which is basically logically every 60 frames, or every 1/60th of a second. And you can just, this is different. But yeah, fixed frame is basically only used when you want to do physics for rigid bodies and stuff. And so what we're going to do is we're going to go up to our start, the first time we've used it, and make not start, excuse me, I'm bad. I need to make this up top. We're going to call a public float. We're going to call that thrust. What this is basically, we're going to make our Mario jump, but we're going to make it jump, however much or however little we want. So make that a huge number because things require a lot of energy to move. And we're going to make another rigid body 2D. Now, if you remember, if we go back to Unity and click on your Mario, you have a rigid body 2D. It doesn't know what it is. It's there, but the object itself doesn't know it actually has it until the game engine calls upon it. So what you want to do is you want to say, "Hey, what's up?" Okay, which part? The rigid body object? Okay, so objects in Unity, they have properties, but they are not for lack of a better word, conscious of their properties until you tell them about it. So it'll act like it has a rigid body, but it won't know it has a rigid body until you actually tell it. So in your scripts, you'll never know it has a rigid body until you tell it does.
Oh, so you specifically have to instantiate the rigid body.
Exactly. You have to basically say, "Hey, script, you get access to my rigid body, but only because I'm telling you prior to this that you should have one." Does that make sense? All right. And then in your fixed update, you're probably going to want to make, if I can go over here, in your fixed update, you're going to go do your regular logic that we did for our get axis. We're going to go instead input, just like we did before, get button down. And there is a reason that it's not get button, and I can tell you that in just a second. And it's really quite funny if you use just get button. And we're going to go, if you notice, we called our rigid body RB. It's pretty shorthand, it's pretty self-explanatory. RB, there's a function for all rigid bodies called add force. And that takes some force and adds it to whatever you want. So transform.up, you know how we did transform.position X, Y, and Z? Well, transform.up is saying, hey, in relative space to Unity, what is up to this object, right? And we're gonna go, okay, we're gonna add force to that like arrow basically. We're gonna go times that or times thrust. If you don't, he doesn't move very much. He moves, actually I don't think he moves at all. It's too weak to make him move. But if we do this, and we go to our game, something really funny is gonna happen. Oh yeah, something really is funny is gonna happen. It's gonna break. Could not be found. Oh, I know why. If you go over to your move script for your Mario, I don't know why it's not updating. Are you missing the assembly reference? I don't know. Am I missing the assembly reference? That's weird. I instantiated. Oh, did I make it private instead? It should be public. It's a public rigid body. What did I do? What did I do? It's questionable. Okay, well, we'll just say in our start, so we don't have to fiddle around with that. It's called get component rigid body 2D close parentheses. Oh, I am not typing that on the screen. I'm typing that in another one. Whoops. That was awkward. I'm gonna type that in start. My bad. There we go. That's what it looks like. That should work. If it doesn't work, I have some debugging to do because this worked last night, and it's actually what I have exactly right here, which is confusing. Control S this. Let's see. Does it update? No. Okay. Because yeah, if you look, I have it right there. It has an RB. If we go to Mario. Oh, yours does work. Interesting. I don't know why. Yeah, I'm gonna just re-add the component, remove component, and then.
I mean, like sometimes error messages show up and they stay there for a while.
Interesting. Okay. Oh, I have it clear on play though. It should be fine. What? Try what? Oh, I mean, it'll just error. It'll say, hey, you don't have your stuff. Yeah. That's so interesting. The type or namespace, rigid body 2D.
Is it because your public rigid body, capital B, yeah, change that to lowercase?
Oh, is it? Really? Am I dumb? Oh, I am dumb. I'm thinking freaking title case the whole time, and that is not what I'm looking for. And then all that other stuff is right. Come on. Show up. Do it. Hey. Alright, that's cool. Okay, so how you add your rigid body is you can literally just go up here and select your rigid body and click and drag. Unity's kind of nice that way. If you don't want to do it that way, you can actually like click on your object in real space, but it's much more pain. Or you can use this little circle, and it'll pull up a little dialog box, which happens to be up on my other monitor, and it'll say, hey, here are the rigid bodies in the world. Pick one. It's always better to just drag and drop because this is contextual. So you'll see rigid body, and when you click and drag your rigid body, you know it'll be the right one. So now, and yeah, I made him jump up really high on purpose. So when you press it, it just goes up really, really high. Kind of silly, kind of not very useful. And he moves really slow because I reset my thrust. Whoops, or reset my speed. What was that, like 10? If I make this like 350, I found to be about, or 250, one of those, to be about the sweet spot for jumping about his full body height. Yeah, there we go. Moves really, really fast, left and right. It's pretty great. Now, if you want to make him fall faster, you can actually edit your rigid body stuff. So you have mass, gravity, scale. So if you want to move like really, really fast down, I don't even think this will let him jump, but let's just see. Oh, well, I don't actually know what happened, but we're gonna.
He faced through the ground because he's being pulled down so fast.
He just destroyed that fucking box. That's great. Let's put it like 50. Even 20 is too big? Oh yeah, he's just too heavy. He's a heavy boy. But if we give it like, let's just say 20 and make that thrust huge again, because this is what I did last night. I was just messing around with numbers. Make that like 3,000. Don't worry, there'll be a 9,000 joke somewhere. There we go. Look at that. So now he jumps really high and he comes down really, really fast. And we can just fine tune this. So you know how in the older games Mario would jump up and kind of fall really, really fast? And that the gravity scale of 1 might just be a little out of your comfort zone. And I'm gonna have to lower this back down lest he fly off into space and never return. Press play. He's just kind of a slow boy. Like he's jumping on the moon. And that's not kind of what we want. Oh, I forgot to show you guys. If you press just get button, this gets really funny. If you just hold spacebar, he's got a jetpack. And it's pretty great. I think he's lost to Oblivion, but it's fine.
Yeah, the reason why it does that is because it's
Yeah, getting button down only has 1 instance, and get button calls it for every time it's true. Yep, you are correct. And yeah, so basically get button down. Get button down can be kind of tricky sometimes. You'll press it and like very rarely will he not jump. This is because Unity has 2 events. And it strangely doesn't call get button down first. It calls get button, which means if you press it just fast enough, Unity will freak out, think you didn't press it, and just go on with its life like it never happened. It's pretty strange. But yeah, so gravity scale is helpful. We can make this like 10. Not 120. Oh man, he'd phase through existence again. And make this like 1,000, which is what I had it at originally, I think. And yeah, full stack is soon. It starts in 15, I think. Yeah, this ends in about 15 minutes anyways. So we'll just wrap it up. But yeah, now you have a nice little jumping sprite. I knew we probably wouldn't get to enemies yet, and we have a little floaty sprite of Mario over there. 2 different animation styles. It's very cool. Very fun. And yeah, that's basically what I wanted to show you guys. If you ever guys, like physics is always a mess in Unity, but it's also a mess in just about every game engine you'll ever mess with, including Unreal. If you never need help, just ask. It mainly has to do with your rigid body thinking it doesn't exist. Like I will tell you that right now, the second you get an error, it's because your rigid body is being treated like a rigid body instead of rigid body 2D, or you never actually gave it the parameter, and stuff will break. So that's the first thing I check. Anything else, just feel free to message me on Slack. And yeah, we're getting places. I need to shut off this live stream.